This is how a simple HTTP request destroyed my .NET code. 8 parameters, 3 overloads, at least 5 if statements, and it started as a 5 lines of code. I'm working on a real .NET service that talks to an external API. The first version was tiny, a method, a URL, a body, done. Then product said, we need a tenant header. Okay, easy. Then security said, we need a bearer token. Sure, why not? Then SRE said, we need correlation IDs. And then somebody said, we need retry headers and metadata and configurable timeout and validation before we even send this out. And before I knew it, my clean little request method looked like this. A constructor with 8 arguments, half of them nullable, 3 booleans pretending to be configuration, and the call site reading like null, false, null, null. Good luck reviewing this pull request. So this isn't a code style problem, this is a construction problem. And in this video I'm going to show you the exact pattern that fixes this problem. It's a builder pattern. And not just a textbook version, not just a UML diagram created in 1994, the real one that I actually use in .NET production code against a real running API. We are going to build it together end to end with a working ASP.NET Core minimal API. Stick around because at the end of this video you'll never write HTTP request message in the same way. Before we touch any code, let me show you what the build pattern actually is, without the text box nonsense. So this is the object I want to create. It's a HTTP request message. It's quite complex. It has required parts, method, URL, auth, tenant, and some optional parts, for example metadata, correlation ID, retry, timeout, etc. Option 1 is to show everything into a constructor. We saw how that will end, so this is a hard pass. And the option 1 is to build it step by step, with URL, with bearer token, with tenant, with correlation ID, with timeout, with headers, and you're going to build it step by step, you're going to validate it, and you're going to build that complex object. That's it, that's the whole pattern. Instead of saying give me everything at once, I say add URL, then the token, then the tenant, then correlation ID, and only when I'm done, package it up. And as I said, right here at the very end, there is a gate, build. That's where validation lives. If something required is missing, the gate slams shut. The invalid object literally cannot exist. And that's the second superpower of the builder pattern. So remember this, the builder pattern is not about creating objects. It's about controlling complexity of creating those objects and doing that step by step with validation at the end. And that's the whole idea. Now let's see what happens when you don't have it. Quick tour of the setup. I have 2 projects. So the one project is the order API. It's a tiny .NET minimal API. It just validates a bearer token, requires an X tenant header, accept JSON order, and returns 200 to accepted. And that's our real API backend. For the testing, we have a builder pattern demo application, console app where massive code lives, and we are going to fix that side. So just to show you that everything works fine, the current setup, we have running our backend, and let's run our console app that will contact API. And here is the console. You can see that's a version 1 without builder. Here's outgoing HTTP request, response, and to accept it. API is running. Now let's look at the crime scene. This is what a real world .NET service looks like after 6 months of features. So version 1, clean, 4 parameters, URL, token, tenant, body. Beautiful. Then somebody needed a metadata, so we added an overload. Now there's 2 of them. And then everything fell apart. 8 parameters, 3 of them are nullable, 1 boolean that means should we retry? And the call side, look at this. So without named arguments, this would be completely unreadable. Null for metadata, you will have true, null, null. What does that even mean? Is false the retry flag? Is the timeout? Inside the method, it's a wall of if statements. If metadata is not null, add a header. If retry is enabled, add two more headers. If correlation ID exists, add it. Every single optional feature is fork in the road, so every new requirement is another if statement. And of course, a manual JSON serialization every single time with the same options copy pasted across every API client we are using. And the validation? Yeah, it's up here, but there is a catch, it's duplicated in every overload. And you can now see this is not object creation anymore. It's uncontrolled construction of the object. And the worst part, every single .NET developer watching this has shipped code that looks exactly like this. I have. Okay, let's fix it. So, same scenario, same requirements, same backend. But this time, we are going to control the construction. Meet HttpRequestBuilder. Step 1. Every piece of state the request might need leaves as a private field. What that means? That means that your method, URL, token, tenant, metadata, retry flag, timeout flag, etc. So first thing, we need every piece of the state of the builder pattern as a private field. Step number 2. A pure static create method. It's just give us a fresh builder and lets the call site read like a sentence. And now let's build parameter by parameter. As you can see, Copilot has some predictions about the methods I need or I should write. So the first method is with method, where we are going to pass method of the HTTP request and we are going to return the same object. The next one will be with URL, the next one will be with bear token, etc. So we have with method, with URL, with bear token, with tenant, metadata, enable retry, with correlation ID, with timeout, and with JSON body. Look at every method. Same shape, set the field, return this. That return this is a whole secret to the Fluent API. Every method hands you the same builder back, so you can chain them. So method with URL returns a builder. You can immediately call with bear token, which again returns the builder, which lets you to call with tenant, and so on. It's a chain of the methods. And now what's missing here is one method named build, the whole reason this pattern exists. So we can create a method which will return HTTP request message. So that's the object we want to create with a build. And as you can see, I have pre-populated method by Copilot. Let's use this. We have a validation to check URL, bear token, tenant. We are going to create HTTP request message object, add some necessary headers, include metadata, correlation ID, and JSON content. So as you can see, all validations lives here. URL must be present, bear token must be present, post and put must have a body. If anything is missing, you get an exception with a clear message. The invalid request literally cannot exist outside this method. And as the last step, I like to add a small wrapper so the timeout travels with the request as a value object. So I'm going to create a public sealed record and let's name it build HTTP request, where I'm going to pass HTTP, and here instead of returning this request, I'm going to return new build HTTP request with a request and timeout. And instead of HTTP request message, I'm going to return build HTTP request. Okay, let's now see the call site, how this is going to be useful for us. So we have create order async, and we are going to have a builder, which is HTTP request builder, and we are going to create a new builder. With methods, we are going to pass HTTP method. Let's say this is a post. we are going to pass URL. Next, with bear token, we are going to pass bear token. Next node in the chain is tenant. And the last one is with JSON body, where we are going to pass body. So now if metadata is not null, I'm going to say builder with metadata. The same is for retry policy. I'm going to enable retry policy. The same is for the correlation ID. I'm going to add correlation ID if correlation ID is not null, and the same is for the timeout. Let's create a build version. So our build is our builder build, and let's just send real HTTP sender, send async. We're going to pass build request, which is our HTTP request message request, and we are going to pass timeout. And that's it. Create with method post, with URL, with bear token, with tenant, with metadata, retry, with correlation ID, with timeout, with JSON body, and build that. You can read that aloud. It's a sentence and it just describes the request. And there are no nulls, there's no positional guessing. If a feature isn't there, the line for it isn't there. If a feature is there, it has a name. And that's it. Same backend, same headers, same JSON, same accepted response. But the code reads like documentation. And yeah, just to prove it, let's test this API with the builder pattern applied. Let's see again program.cs file. So let's copy this. Let's say version 2 with builder pattern. Let's create demo with builder pattern. That will be completely the same. Just instead of messy, I'm going to use order open API client clean. Let's firstly run our orders API. Orders API is running, and let's run our console application builder pattern demo. So we have version 1 without builder, version 2 with builder, and you can see it's completely same. So let me put them next to each other so the difference is impossible to miss. The first thing I can see here is readability. On the left we have null, false, null, null. On the right we have a chain of name methods like a receipt. There is no context. Another one is extensibility. Tomorrow product asks for the idempotency key. On the left, a new parameter on every overload, new if block, every color breaks. On the right, one new method with idempotency key, callers who don't need it never touch it, and you have zero breaking changes. Also testability. The builder produces a value, which means that you can test header assembly with a simple bin, then assert. No HTTP client at all. No mocks, no integration test required to verify your headers are correct. The thing we already mentioned, validation. One place, centralized, tested once, impossible to bypass. Here we can talk also about intent. The messy version tells you how a request gets built. The builder version tells you what the request is. And that's the difference between code that runs and the code that explains itself. So if your constructor has 8 parameters, you may not have a parameter problem. You may have a construction problem and the builder pattern is fixed. Honestly, the only reason I can look at the method and instantly tell you that's not a parameter problem, that's a construction problem, is because somewhere along the way I stopped memorizing rules and started training my pattern recognition. And the place I personally go to keep that muscle sharp every single morning before I even open my work laptop is brilliant. Right now I'm working through one specific course on there, thinking in code. It's the closest thing I have found to what we just did in this video. You solve a tiny piece of logic, you see what breaks, you fix it. The next puzzle gets a little harder. It's the same refactoring loop I use at work, just compressed into 15-minute sessions I can actually finish before coffee. And one thing I appreciate about Brilliant, it's designed for ages from 10 to 110. Whether you're a senior .developer, or your nephew is just figuring out what variable is, you're both on the same platform leveling up. I love that. So here is a deal. If you want to excel in math or coding, go to brilliant.org/TheCodeMan, which is my dedicated link. It's pinned in the description, and you can also scan the QR code on screen right now. Either way, it gets you to the same place, a 30-day free trial of everything Brilliance has to offer, and using that link directly supports the channel so I can keep making these videos. So 30 days, full access, no commitment. And speaking of sharpening patterns, the builder we wrote earlier is already solid, but I want to share the 3 upgrades I personally make to every builder I ship to the production. These are the things that took mine from good enough for a demo to I never want to write request code any other way. Let me show you that. Upgrade 1, retry validation. Right now, I only check if URL is null, but build method is perfect place to enforce some real business validation, some real business rules. For example, reject a JSON body on get because you don't need a body on get, or reject retry on non-idempotent verbs if your team has that rule, etc. You can build a stronger validation inside of build method. Upgrade to preset. So in the real code base, you're going to call this API 20 times from different services with the same base URL, same tenant, same timeout. And you should not repeat yourself. You can make a static factory, for example for orders API, that returns a half-built builder with all the defaults already set. The caller only fills in what actually different. The builder pattern composes beautifully. So let me show you that I have that prepared. So you can have orders API options with base URL, tenant, bear token, default timeout, which you're going to get from some app settings or environment variables. And you will have 4 orders API that will accept that options with a relative path. And you're going to create that builder once for all orders API calls. And upgrade number 3 is the most important upgrade here, knowing when not to reach to this pattern. If your object has 2 or 3 required parameters and that's it, you really don't need to overcomplicate it with builder pattern. The builder pattern is useful when you have many optional parameters, conditional pieces, some validation rules, or when the call is unreadable at all. If none of those apply, you're just adding ceremony. The simple rule I use here is if I'm tempted to write a third constructor overload, that's the moment where the builder pattern pays for itself. Let's land this. The builder pattern is not academic. It's not textbook curiosity. It's the answer to a problem that every backend.NET developer eventually hits. Object construction that grows out of control. When you see 8 parameters, think construction problem. When you see a wall of if conditions inside a constructor, think a construction problem. When you see overloads multiplying, think construction problem. A builder gives you 3 things at once: a readable call sites, centralized validation, and future-proof shape that absorbs new requirements without breaking old ones. And remember, the builder pattern is not about creating objects. It's about controlling complexity. So if this clicked for you, hit that subscribe button. The full source code of this video is in description completely for free, including the minimal API project orders API that we have as a backend API. So you can clone it and play with the builder. Drop a comment with the next design pattern you want me to talk about. I read all the comments. Also check my 2 ebooks about design patterns in the description. You will have some discount codes for that. And until next time, write less code, control more complexity. Thank you for watching this video. See you in the next one. Dream big.